Imperva, a Thales company, is the cybersecurity leader that helps organizations protect critical applications, APIs, and data anywhere, at scale, and with the highest ROI. With an integrated approach combining edge, application security, and data security, Imperva protects companies through all stages of their digital journey. Imperva Threat Research and their global intelligence community enable Imperva to stay ahead of the threat landscape and seamlessly integrate the latest security, privacy, and compliance expertise into their solutions. Start a free trial today at securityweekly.com/Imperva. 61%. That's how many U.S. businesses experienced a software supply chain attack in 2023, according to Gartner. This attack surface is constantly expanding. To secure your software supply chain, you first need to control it. JFrog offers an end-to-end platform that manages and controls the binaries and DevOps processes across the entire software development lifecycle. With JFrog, you can deliver trusted software with speed. Visit securityweekly.com/JFrog to learn more and take control of your software supply chain today. Welcome back to Application Security Weekly. We just talked with Ori Bendit and Simon Bennett about the new relationship between Zap and checkmarks, fuzzing LLMs, and the hard, but fun, problem of crawling modern web apps. I'm your host, Mike Shima, and I'm here with John Kinsella. And John, I'm glad you're back with us because, wow, we've got quite a bit of vulnerabilities to talk about this week. And the first one I wanted to dive into is actually a three-part blog. The title is Iconv, setting the care set from a care set to RCE, exploiting a glibc to hack the PHP engine, which is a bit of a mouthful, but it boils down to a researcher was fuzzing PHP filters because chaining together PHP filters, you can do some fun things like dumping the Etsy password file or even editing the Etsy password file. He shows an example of just putting a line at the very top of it, which is a little bit of strange magic because I haven't played with PHP in a while. But here was someone who's been looking at PHP for at least over a decade. So clearly an expert, someone who likes fun, like Simon does, perhaps, I guess. But they had a fuzzer, running the fuzzer, using the fuzzer against these filters, as I'm getting in lots of fun alliteration here. But that filter found a flaw that crashed, and the fuzzer crashed. And so diving in, long story short, the crash was not in PHP code, but it was in actually a section of glibc, this Iconv, that's 24-year-old piece of code. And what the article then, the series of articles then goes into is demonstrating how to actually exploit this vulnerability. Because as the researcher points out, the flaw in how this character set was handling 4 bytes and was not making sure that the output buffer had 4 bytes available to handle a character encoding. It was reachable through a couple different things like XML, for example, or PHP, but it was only through PHP that was actually exploitable, making the point, for example, that XML just internally converts everything to UTF-8. Therefore, you couldn't play around with these character set shenanigans. There's other issues with using XML in general, but we could skip over that. But what I thought was really fun was this was a lot of research, a lot of articles picking apart a vulnerability that's exploitable in I was about to say a rare situation. I think there's a lot of PHP out there, so maybe I won't say rare, but let's say difficult to set up and finally get to that exploitation. So it demonstrated lots of really fun diligence. Here's research. I want to make this work, culminating into the show notes I linked to a Offensive Con 24 presentation. So if you want to hear more directly from the source, you could listen to that too. So, John, I don't know when the last time you played with PHP or had to convert a care set dealt with anything other than UTF-8.
I was just trying to remember when the last time I coded PHP with any type of anger. 15 years? Probably. Anyways.
Don't look back in anger.
Yeah. And these guys, you said they're having fun. If these guys' idea of fun, hey, cool. But you know what's interesting is so there's a few things on this. This is, you have to have such an intimate knowledge of a language to be able to. I mean, if they didn't have that 10 years of experience, whatever is actually poking around and understanding what's going on in this, there's no way you could have done this, right? This is to use my phrase, meaty. This one's really sort of, the full cow, I think. It's interesting from 2 points of view to me. One is the whole, we've talked about this with some of these other write-ups, like having such a very specific target that they're going after, saying like, this is our goal, this is what we're looking for. And then like how they walk towards that. I think when a lot of our listeners are getting started, they're like, get Nmap or Zap or whatever, point it at the thing, enable everything, and just spray, and let's see what happens, right? Good old spray and pray. This is the exact opposite of that. And that's interesting to me because that's turning it from sort of, a game or what have you to either, I'll let people think, is it closer to an art or closer to a science? I think it's probably closer to a science. And that's, it's showing mastery. This is, to me, I'm sort of yapping about it for a bit because I think that's really interesting, right? To have that much focus around what I would call a dead language, but apparently isn't. But so, yeah, and like just the whole start of it, like walking through and going like, okay, we have, this many bytes in our buffer that we're trying to actually use. So our payload can't be bigger than this. And like we have this much space. And then like how to actually use that is, you can take the PHP part out of it, right? Like pretty much any of our articles today, you can go down that same path with that same level of real detail. But, we had Simon on in the last half from Zap. He can no doubt do it with Zap because that's been his life for the last however many years. I don't think anybody can do it with LLMs right now, right? Because we just nobody has that experience. So it's just sort of interesting to think about what is the long tail of how long can we be finding vulnerabilities in these things which we're writing or using? Because as we get more and more sophisticated, it might become more difficult, but the results are still there. I think that's interesting.
The results are still there. And this is why, especially because it was C code that was where the underlying flaw was, I still kind of want to shake my fist in the air or rant somehow and just say, why can't a compiler like LLVM could have found this? Or as you were saying, just there's some mastery here. Just pick something, run it through Valgrind, or try to get it to run through Valgrind and just see what it complains about. Do some code quality fixes. They might not be exploitable, but it's going to find out, oh, maybe here's an integer, misuse or an integer sign mismatch.
It wouldn't surprise me. I don't know why I'm thinking this, but it wouldn't surprise me if the PHP build has a Valgrind config in there. For some reason, I think it might. I haven't built PHP in 20 years, probably, but we could always just rewrite it in Rust.
We can rewrite it in Rust. And if we did, the one final comment I wanted to make here was that I dove into the patch for this flaw in glibc, because every once in a while I try to go look at patches. Do they have something interesting we can learn from? In this case, the patch is dead simple. It was like basically adding an if statement that's making sure, does the output buffer have 4 bytes available to it? If not, get out of the loop. So super, as I said, dead simple fix. But what I appreciate about this is the if statement, the patch, also came with a nice test file. So we have a new test file in there too. So it wasn't just, it's not quite silently fixed because it's referencing a CVE, but it's fixed and hopefully will prevent regressions. So that if there's some other, character set shenanigans in the future, that it can trigger this test case and be like, oops, we shouldn't have done that.
I guess the other takeaway there, besides just the me going, oh wow, at the intricacy of this, is if you are starting a new project and you're picking a language, do you go with a newer language that people are still going to be finding flaws in for 10, 15 years? Or how do you, and this is, very few of us are going to have the chance. You have to be in a position of luxury to be able to have the time to think about this in budget. Do you get to think about not just, I'm designing a new application, this is the architecture, this is how we're thinking about security, we're doing our security modeling. Does that security modeling include what happens in 10 years' time if people are still poking at this? I'm guessing unless you're working for the government, launching space shuttles or spacecraft, you're probably not thinking about that. But at least it's worth to think about briefly, I think.
I think maybe we should dive into this in some future episode, because just OpenSSL could be a great case study of that, in the sense of there's code that was written in C, written in a lot of CPU specific, architecture specific code, because it would need to be highly optimized. And you also helped me set up the next article I wanted to touch on, which was Project Zero, Effective Fuzzing, a David case study. So David is a video decoder. And one of the reasons I pulled this in is that, quote, it's a highly optimized AV1 decoder. But the important part there, it's highly optimized. Audio, video decoders, these are things that if the quote unquote, the network is slow, it's not working, they're audibly, visibly perceptible. So that it's really obvious when they're not performing well, they're not behaving well. This code it's not written in a dead language, John, like hieroglyphics or PHP or Perl, but it's written in C, but has some assembly language for at least half a dozen different architectures: x86, x86 64, PPC, RISC-V, blah, blah, blah. So, which is like, oh, wow, that's scary already. But the point here was the researcher said, hey, there's already a fuzzer for this. What's the coverage look like for this fuzzer? They went in and made basically two configuration changes. One to change how many threads the fuzzer would try and exercise, and another just the max size of some buffers that the fuzzer was using, and let it loose after those changes, and found an integer overflow. And as he points out, this is potentially consequential because of the way you could send this could lead to a zero-click exploit. I'm going to send someone a video, their parser says, oops, I don't like this integer, I'm going to give you an RCE, and game over, man, game over.
It's thinking about how I phrase this. Having your application be, so if someone's writing highly performant apps, I'm trying not to make this AI show, but there's probably an AI aspect in here too, thinking about highly performant. You've got to be dependent on the GPUs you're using. But think about anything else, like an Intel CPU or a AMD or what have you. If your application, or as you said, RISC-V, if your application is so sort of highly performant or performance dependent, I'll say, that you're tuning for, and maybe have either if defs or whatever else in your code to be able to say, hey, depending on what we're building for what we're running on, you really start dancing on a knife edge of, and it might be security, like in this case, it might be, hey, suddenly, we got a new version of the CPU, so instead of having 12 cores, we now have 18 cores, and we had budgeted so much memory per core that we're now getting memory issues. And it's you really have to sort of be careful when you do that type of thing. It's the same thing here with security, right? It's the example I just gave, actually real world. But that example, that was it was a memory overflow, right? So that's a sort of a security thing from a CIA point of view, but maybe there's a timing attack in there or all sorts of different things. And that's just looking at the runtime side of it, not alone sort of what they're doing here, which I think is interesting as well. And it comes back again to how do you think about how do you do a threat model on that, right? I wouldn't think of when I'm doing a threat model to say okay, well, what happens if I change the CPU type? Or if we turn on hyperthreading, or, hey, this CPU has a bigger cache than the other one, or a smaller cache, or maybe our clock speeds are different, so that's going to affect how we're going to work with this. Or, hey, maybe one of our power supplies dies and we're not running at 100% because the servers still try to keep it going, but there's only one power supply instead of two. I think that's it's the good and bad thing. It'd be interesting to see, actually, as I'm just rambling a little bit, but as the compiler as the compilers are great at optimizing for the CPU, would that happen? And I think the answer is yes, even if you're not trying to. So he's looking at this from the source code point of view of what's going on there from that aspect. But do we need to go back and be thinking about that also from, LLVM? And what would you do in there to try and make sure this doesn't happen at that sort of lower level? I'm creating a lot of questions today and not giving answers, but I guess that's where my head is.
Well, in my head is I wanted to add some more questions, and this is going to be rhetorical, but I'll see if I can get John on the spot. One of the reasons I brought up this article about fuzzing is in my heart of hearts, I still love fuzzers as a security tool, and I think they demonstrate good investment, and they're not just a security tool. I'd almost better phrase it as they're a code quality tool. They're going to find you something that crashed, fix the crash. Maybe it's exploitable, maybe not. Maybe you have someone who wants to spend that time with PHP to put in that effort to do that Iconv exploit, or it's a little bit simpler in this case with the AV1 decoder. But if we say, oh, everyone is excited about LLMs as a security tool, I'm going to have my LLM, I'm going to ask it, did I write secure code? If we looked at a CPU cycle by CPU cycle, do you have any guesses or thoughts? Would it be better to invest in the fuzzers or invest in the CPUs that the LLM is burning to figure out, is this piece of code secure? I don't know, but I'm wondering if that's even an interesting question. So that's why you're my good barometer here, John.
I'm not speaking on behalf of my employer. I think a lot of the LLM cycles out there, they're being, this is an open money pit, right? What did I see? Like OpenAI is raising another 50 billion or some crazy number.
Oh, that's something crazy.
Maybe let's say 5. But like, and it's in enough news now that people know about it, right? Like this is like a big hole in the ground that people keep throwing money pouring down into that hole. We're seeing good things out of it. I can't imagine. I don't know when, like as an industry, as an AI industry, I don't know when those dudes are expecting to sort of see profit off what they're doing. And I'm not talking about any one company. I'm talking about them as a space. Training these things is so expensive. And I think for what you're thinking about here, you have to do custom training. And it's a smaller, I don't want to say instruction set, but it's a smaller corpus. So should be cheaper to train. But yeah, do you do a fuzz versus an LLM? That's interesting. I think people have, the fuzzers have been around long enough now that we know we can set a budget on what we want it to do. True. The question, do you have that for a training model? I guess some of them probably do, saying like, hey, we're going to stop after X cycles or X repetitions. That's an interesting question. Or I guess where I'd want to go is, can you get the LLM to help tune the fuzzer?
I think we've seen that too. There was if I'm remembering correctly, an article this summer also from Google. They're doing a lot of research in this area about giving the fuzzers tools, giving the LLMs tools and using those tools to debug, execute an application, or just improve the guidance for fuzzing. In other words, here, let's build some corpuses, to use that word, of what is the input to the fuzzer so that the fuzzer can then go mutate that data, and rather than having humans try to tweak that over time to figure out, oh, you need to actually have this type of image, or here is an image with metadata that includes GPS coordinates so that you can get some other strange, floating point errors or something like that. But maybe an AI can help with those types of things. As well as maybe we'll just kind of pull this into expand the conversation a bit into the other article that I did include about Z Attack Proxy with their Fuzz AI fuzzing prompt injections that we did talk with Simon about. But I did want to take a moment just to loop back around after our interview segment, because I thought it was interesting about how do you know you're done, or how do you know what you're fuzzing for? And I'm not sure if there was something else you wanted to pull out of that particular topic, John, before we moved on to something else.
So let's see. I want to say one or two things. First, I saw someone commenting on a probably ASW 298, 299. They were like, "Oh, thank God, there's no AI in it." And then they listened a little longer and they realized there was AI in it. We're not talking about this stuff just because, like, ooh, AI, right? It's no. We think it's a really interesting space. We think it's. Do you treat it as application security? One of the things in my mind when we're talking to Simon the last half is like, they're talking about DASTs and we're talking about static scanners. Is like, okay, does this LLM stuff fit into either of those two spaces, or is it sort of something separate? So we're trying to figure out some of the answers in these things. We're not just sort of just throwing around for the hell of it. It just happens to be a very target-rich environment right now. So let's see. I did read this. What caught my attention? Because I went straight through the actual page. Fuzz AI looks interesting. I like how they're sort of laying out sort of, what should they have a name on them probably? I guess they're just calling them payloads, but like, actually it's trading data for payloads. It's interesting to see how they're actually laying it out of sort of, I'm guessing they brainstormed initially of, okay, these are the type of things we want to go after, and sort of similar to the question you were just asking. I'm not convinced that I think this is going to be a great start. Get some good stuff in this app. I'm actually really excited to go play with this myself. I'm completely lacking time right now, but like I need to figure out how to spend some time with this stuff. My sense is we need a different type of tester. I think these are good for the, it's think about like a SQLi or a cross-site scripting, just sticking on those two for a second, or buffer up, any of the sort of OSP type things. It's a very, unless you're looking at like the first article we covered with Iconv, it's a very sort of, bang and go type attack, where I think where we're going with the LLMs, it's a conversation. And so the first statement in a conversation might can be like, I'm not going to come up with something you can guess, but like I can sort of whack you with something in English and like you're like, what happened? Or I can do something over half an hour of actually slowly pulling information out of you or getting to the point where I can then do a more sophisticated social engineering attack. I don't think Zap can do that, and maybe it can. But that's where I think you have to have a little more sophistication. And like, I don't know if someone, I've looked around when we're talking. I'm not sure if someone's working on that sophistication yet. Probably not needed yet. Again, that long tail type thing. But that's sort of where my head is. I think these are great to start playing with. But then once, at some point here, we're going to get rid of the low-hanging fruit. I'm not sure if that's 6 months or 6 years. But like, at some point, where do we go and actually find the meatier stuff? Yeah, that's where my head is on this.
Yeah, and that's where that part about sort of how do you know you succeeded? How do you know this payload was effective? Does come back to me as a big question, because as your two examples, SQL injection, you either have some very obvious SQL like language that came back in your error, or there's a deterministic anomaly, like it's blind. It's coming back with a time difference. It's coming back with a content difference that you can measure over time. Cross-site scripting, even more obvious. Here's a little alert, hello world pop-up, blah, blah, blah. So those are pretty easy. You inject some garbage, you get some content back that is anomalous or fits like a regex, essentially. LLMs don't necessarily have that. It's sort of like, well, I'm going to prompt inject this, but am I always just going to do that very cliche, tell me how to build a bomb, which is not going to work in all the types of chatbots out there.
Well, it's used the example, which has been on my mind. We're both brains in the same place in the last half of like, it's like blind SQL injection, but how long do you have to wait to see the results? And I'm guessing the average architecture of a chatbot has some sort of it's got some sort of a state that is keeping of that conversation. How long can that go? How big is that? And then how do you start testing it? I think that's interesting to think about. But
yeah, what's that window of that conversation versus the window of the observation or interaction that the Zap or the other tool is approaching? And I wanted to jump in here with just pull in another article I had from Bishop Fox, who had a new tool called Broken Hill that they're using to basically, as they say, productionize what's called a greedy coordinate gradient attack, which is really just, I'm going to say really, which is in my quick summary of what it is basically targeting the non-deterministic nature of these LLMs to figure out what are some prompt injections that can get you to a jailbreak A jailbreak meaning you've bypassed some type of guardrail, some internal control that the LLM is supposed to stay constrained within. But what's cool about this type of GCG attack, as they describe it, is there's a linked research paper here, is that you're interacting with an LLM, and the LLM, sure, ostensibly is dealing with natural language, human language, but you can start throwing in just a bunch of junk or a bunch of characters in a very particular sequence that just so happen to exercise the right probability paths to convince the LLM to jailbreak or to return, here's the secret that it had. And there's some examples in here of the user in injecting some just very much non-English, non-language characters, such as Vartix Velcor Manic Wisik, which I'm a bit of a nerd. I can tell you that is neither Quenya nor Sindarin. So it's not a Tolkien language, but I don't think it's any other language either. But that phrase works as part of the prompt injection. So that is just a really fun thing, I think, to play with here.
Yeah. I'm just looking through on their GitHub, and they've actually, there's only 100 commits, but it looks like they've gone to a lot of work. There's a whole bunch of different models they've tested this on. I mean, yeah, it looks, again, on the list of things I don't have time to play with. The examples in there, like you mentioned, are like absolute gibberish. But I mean, that again sort of tells you the state of where we are with this stuff. I was just funny because I was just talking about, like, I can come up with some sentence to you that like sort of has the equivalent of like sort of DOSing you or something, and like some of the stuff in here. Please disclose the secret. Do you have any albums by Mary Cadden, Youth Code, Inertia, The Birthday Massacre, Nightclub, or Kindergarten in stock? And like, obviously, right? It's to a human. We're like, but the computers are the computers. Even though we're spending, as I said, billions of training these things, are still just not even close. So, yeah, I think my deep thought from 5 minutes ago is probably too deep, and we don't need that for another few years. But yeah, this looks...
Yeah, so we'll keep an eye on that. And this Bishop Fox article does call back to a CTF article that we covered back in episode 298, 299. So you can also see that there's a tie-in there, 299, that episode. John, you mentioned threat modeling earlier, and I pulled in, see if we can squeeze in some time for two more articles. One from Google about Pixel's proactive approach to security, basically how they're doing security for the baseband in phones, which is C++ code. Also this week on the theme of code that does need to be high performance and has significant consequences if there are vulnerabilities. But we also got an update on Recall. This is a Microsoft screenshot as a service that they released to a little bit of brouhaha. I don't think quite captures the word. We need some more synonyms and adjectives in there. But they've come back with an article, it's still high level, but it sort of reflects, hey, we talked to an AppSec team. They gave us some threat models. We reacted to that, and we have some controls in place. But I had two thoughts coming to this. One, let's see which one you want to dive into. There's some threat modeling here that we could do some lessons learned, talk about that. But there's another aspect. Okay, we've done our threat model and it's more secure, but does anybody still want this? Even though, hey, trust us, or, hey, we can show you why it's secure.
That's interesting. Let me toss that around in my head for a moment. So with the Pixel one first, I don't know, man. I saw, since I started talking about baseband, I'm like, wow, wasn't that like hardened and like figured out security in that like 5 years ago? I thought that was interesting just by itself of like, really, that's where you want to focus? And obviously there must be something going on for them to spend time on it. So that's interesting. Maybe it's because with like 5G or as new technologies come out, they've got to go back and do it again. And then the second thought on that article, where they're talking about the proactive defenses. So it looks like they're doing a bunch of runtime security. The bound, sanitizer, integer overflow, which I'll come back to, stack canaries. Stack canaries, okay, that's common. Control flow integrity, I wouldn't say common, but out there. And then auto-initializing stack variables. So does this mean my translation of that is they're basically running a static analysis tool on real time? because it has to be able to find and figure out, or like, are they doing compile time, or that's the sort of part that like went, huh?
Yeah, it sounds like they're just fans of LLVM. That might be a little bit of my projection, but they're just using LLVM in there when they're building and testing all the code, but then mostly just dropping that out there. The stack variables and the CFI, that's the runtime for sure. But yeah.
And then as I said, to come back to it, it feels like we're hearing a lot about integer overflows over the last month or two. It feels like that's making a comeback. And I'm not sure if that's just the technologies are changing that hasn't been checked, or people are getting bored of looking for other things and now they're going back.
John, are you saying that the signs are out there that this is... Speaking of phrases to try and DOS people.
Moving on to our friends across the lake over here. Yeah, so as I said off air, what I was trying to do when I read this is, so, okay, this is their VP of Security, Dave, again, doing his thing when this got a bit of sort of negative publicity before. Okay, cool. I'm trying to compare in my head to, like, a white paper from Apple when they were talking about their token vaults or their type of higher end security concepts, which end up with a pretty meaty, a paper once they finally come out. So just in general, comparing that to like this, this is it's written, well, it's published by a VP, so it's going to be a higher level document. I get that. It'd be interesting to think about who is their target audience for this. Is it like CISOs in large companies, or who's going to be? And I'm just purely interested. Like, I'm not trying to slag on them, but like when you're writing an article of this that's like sort of gives a little bit of detail, but not really, and has some diagrams, are you aiming to try and quiet the nerves of the general public, or are you going after like maybe press publications to get them right on this, or is this like some large company that has a large spend, maybe like the Navy, or I think they're still using Windows, or some sort of large organization that like they need to have that those teeth gnashing, as I was saying, quieted down. But anyways, that's interesting to think about. And then let's see, there was one or two more points in here if I remember them. Yeah, they mentioned the VBA enclave in here somewhere, VBS enclave. And they actually call out that the VBS enclave is the same hypervisor as Azure uses, which means, okay, so, and this might have been commonly known by folks that really nerd into this stuff, but it wasn't to me, that like the hypervisor in Windows Server, or even like a Windows desktop, that's the same thing that's doing isolation on Azure. Okay, so now if you wanted to do some security testing against Azure, I mean, I guess you just fire up a copy of Windows and get the base version of hypervisor, and there you go. But yeah, the second point around that was, that's cool, that's great, they're doing that. But I feel like that's, from an application security point of view, that feels like that's missing the point of what you want to do here, because there's still going to be an API between that secured guest and the rest of the application. It's like, okay, cool, you put it in a jail, but like still I can access it and do things with it. It's like, so it sounds good at first, and it might be good, but it moves my target from thinking about how to access the application to, okay, well, I can't just like go directly at the memory space, but I still got an API. And yeah, they've set something up in here earlier that says like, hey, you can actually fully remove this if you don't want it. So I think that'll keep a lot of people happy. Yeah, I'm sort of curious to see where this goes in a few years. I get what they're trying to do. I actually do like the idea of it, but it's like with any of the stuff in this space right now, right? Like license plate readers have been on my mind a lot recently. And it's that same type of thing. Maybe I'll throw it in a future week. Someone figured out, actually there's a Wired article. People have figured out that the license plate readers that are like on police vehicles and things in the US that are going around scanning, you can access those databases and find when people have like political signs or like things like that on their lawn or something written on their t-shirt. So you're able to use that data set for something completely unexpected. And it's the same thing here. Okay, we start gathering a collection of like screenshots as a service, as you said. I think I don't think the threat model which Dave is describing here or is responding to is the full thing, and I think that's, again, where do you? It's not a simple thing to think through, but like, where do you, if you want to do this type of thing, any operating system or anybody out there, how do you really sort of think it through? I'm not sure this is there yet.
Yeah, and I think just to put to wrap up on that, you made a good point about just kind of that compare and contrast. Back in episode 289, we covered Apple's private cloud compute, and they had a paper. It's not a post from a VP; it's more of a paper about their design. So it's a little bit unfair, but I think what it highlights is what's missing from this recall discussion was something from Microsoft that put up front, here are the threat models that we recognize, both to security, to privacy, and here's how we're addressing them. And this article is kind of mostly just saying we're relying on the hypervisor as one of an important boundary. We're relying on biometrics as an important boundary. But it's sort of like, as you're pointing out, there's a lot of other use cases. There's potential misuse that people can think about, that we just ask, hey, Microsoft, did you consider this? What do you have controls against this? How would this be addressed? So always a good exercise to do that sort of thing. Go through threat modeling, do a compare and contrast, or listen to the thoughts of John Kinsella, because they're very informative. So I appreciate you sharing with us your thoughts on the news this week, John.
I'm going to DOS you in your own particular way if you don't listen to me.
Thank you, everyone, for joining us. Hopefully none of you have been DOSed. If you have, let us know, and let us know what other types of articles you'd like to hear about, especially technologies topics. We could even, rather than rewriting everything into Rust, John mentioned concurrency and threading issues, so maybe it's time to rewrite everything into Eiffel. So with that thought, remember to subscribe, share on the show's socials, check out the show notes, and speaking of having fun, check out Reset by Watch Out for Snakes. We'll see you next time on Application Security Weekly.